Now let's look at an example of an application. Example 5 says the length of a rectangle is 5 less than twice the width. The length of a rectangle is 5 less than twice the width. The area of the rectangle is 150 square feet. Find the length. The length of a rectangle is 5 less than twice the width. The area of the rectangle is 150 square feet. Find the length. We have 3 dimensions of this rectangle that are mentioned in our problem. One is length, another is width, and the other is area. We need to have some expressions to indicate the length, the width, and the area. So let's list those 3, the length, the width, and the area, and come up with expressions to represent each one that we can then put together. For the length, we're told that the length is 5 less than twice the width. 5 less than twice the width. 5 less than means we will subtract 5 at the end. Twice the width means 2 times whatever we're using to stand for the width. What do we use to stand for the width? Well, let's call it x. So the length is 2x subtract 5. For the width, we just made our decision. The width, we said, is going to be represented by x. The width is simply x. Now, you should recall that in every word problem, one expression must be represented by a single variable. In this case, it's the width. The width of this rectangle is represented by a single variable. Then the area. Well, the area is, there's no question, 150 square feet. Let's leave the units off now. As we work with these numbers, we'll come back to the units at the conclusion. So the area is 150 square feet. We'll simply write the 150. Now, how do we put these together? You should know that in a rectangle, the area is found by multiplying length times width. So we have area is equal to length times width. Well, the area is 150. The length is 2x subtract 5. The width is x. Notice that we have a number and then a factored expression. We must get this quadratic equation in standard form. That means that we simplify on the right-hand side. 150 equals, multiplying this, we get 2x squared subtract 5x. 0 must be on one side of the equation. The way we've stated it in our rules is we want 0 to be on the right-hand side of the equation. Now, in an equation, recall that it's perfectly legitimate to switch sides. The right-hand side may be written on the left, and the left-hand side may be written on the right if it feels more natural to us. In this case, I think it will be helpful if we do that. So let's pick up this piece, 2x squared minus 5x, write it on the left-hand side. No changes to it, just write it on the left-hand side. Then the equals mark. Pick up the 150 and write it on the right-hand side. So we have 2x squared subtract 5x is equal to 150. Now we're almost in standard form. We simply need to get rid of the 150. So we have 2x squared subtract 5x subtract 150 is equal to 150 subtract 150. And that gives 2x squared subtract 5x subtract 150 is equal to 0. Now we need to factor this one. Well, the 2x squared is going to be 2x in the first set of parentheses and x in the second set of parentheses. For the factors of 150, we got quite a long list. 150 can be 1 times 150, 2 times 75, 3 times 50, let's see, 5 times 30, 6 times, what would that one be? $25, 10 times 15. Well, the list is quite long indeed. And when we try this whole list, it turns out that the 10 and 15 pair will do what we want. Notice that 2x times 10 will give us 20x, and 15 times x will give us 15x, and we want the 20x to have the negative sign. So we get 2x plus 15 times x subtract 10 equals 0. Now we must set each of these factors equal to 0 and solve. We get 2x add 15 equals 0. If we subtract 15 from both sides, 2x add 15 subtract 15 equals 0 subtract 15. Then we get 2x is equal to negative 15. Then divide each part by 2, and we get x is equal to negative 15 over 2. For our other factor, we have x subtract 10 equals 0. Add 10 to both sides, and we get x is equal to 10. Here are two results that satisfy our quadratic equation. Do they satisfy the problem? Remember that we check the problem in the original.